combinations. So yesterday, what was the difference I said between combinations and permutations?
Permutation is the order that you're selecting out of.
The order selected method, right? So now a combination, all you're doing is you're just selecting. So for example, they say all the diamonds from a standard deck of playing cards are shuffled and 4 of these cards are dealt in a row. How many different permutations of 4 diamonds can be dealt? Okay, so that question may lead you in nicely to let you know that it's actual permutation. Okay, because it specifically says that. So how many different permutations? So use our calculator. 13p4, right? Okay, so punch that in your calculator.
17,160.
Okay, and what's important about this is the order is important in this. So if it says then that suppose the order does not matter, how many different combinations could be dealt? So now, not only do I have the 17,160, I have 4 cards that I picked, correct? How many ways can I order 4 cards? What is it? 4 factorial, right? Because you got 4 choices on the first one, 3 on the second, 2 on the third, and 1. So you would divide that by 4 factorial. Well, that's what a combination is. 13C4, okay, looks like a permutation right here. So 13 factorial over n minus r, which is 9 factorial, right? And then I have to also divide by the number of ways, the r factorial, the number of ways in which I can arrange them. So when I divide by 4 factorial, I end up with only 715 ways, okay, in which there are combinations. All right. That's basically all we need to do for right now. We will get into a little more complicated questions in terms of in which we need cases for, but we don't need to delve into that just yet. Were there any issues with 4.3 or 4.2 yesterday? Anybody have any questions? 4.2 was just factorial notation. What about 4.3? Any issues? What question 5? Anybody have any issues with question 5? State the values of n for which the expression is defined, where n is an integer. So n factorial over n minus 2 factorial. N has to be greater than what? Did we do that or not? No? Are we just not there, or we just didn't do it?
I just got there.
Yeah.
You just got there? Okay. Okay, well, let's start the first one and let's see what happens here. All right? Now, what do we know about factorial notation? What does n have to be greater than? For me? 0. Okay, we can have 0 factorial. But so is it 0 that we have to be greater than or equal to? Yeah? Okay, so because you can have 0 factorial because that's equal to what? 1. Now, I never explained that to you yesterday. I just said, okay, you understand that 0 factorial is 1. But why is that? Why does that work that way? Does anyone have any idea? How many ways can you pick all of something? Okay, and how many ways can you pick none of something? Right? So if I had 10p0, in which I'm not selecting any of them, correct? It gives me what? 10 factorial over Well, 10 subtract 0, n minus r, would be 10 factorial, which is equal to only one way in which you can do that, correct? Right? Okay, so that's why 0 factorial is equal to 1. And they show that in that tip, right? 0 factorial is defined to be 1. Okay, so if you have n factorial, which is the larger of these two? Top or bottom? The top is, so I'm going to expand the top. What's the top expand to? N minus 1, n minus 2, factorial. This cancels. Alright, so it leaves me with n times n minus 1. So how do I find out what n has to be greater than? What does n have to be greater than in this case? What's the smallest value there that I have remaining? N minus 1. So what does n have to be greater than? Has to be that, right? So then n has to be greater than or equal to 1. Okay, so that's how you do those other two questions. Okay, so you have 4, 3, and 4, 4 today. And then I doubt you'll get to 4, 5 if you have all the 4, 4 to do. There's quite a bit in that permutation. Actually, I have one more thing that I want to look at. I didn't show you yesterday, I want to show you just right now. And that's example 2 on page 101. This is a neat question, and there are two ways in which we can do this question. So today I'm going to show you the slick, quick, fast method of it. All right, and then we will have to look at the expanded method for that they do and apply for this because they change it a little bit. So Ricardo jumps into a taxi to travel 8 blocks west and 3 blocks north across the town. Assuming there are no one-way streets, how many routes could the taxi driver take traveling, only west and north? Okay. So I want to go, how many blocks total? 11. And how many of our turns repeat? Well, not necessarily turns, but how many ways can I go? Okay, so yes, go ahead. 2 ways. I can either go west or north, right? But how far west do I have to go? 8 blocks, and how far north do I have to go? 3. So I treat this exactly the same thing as a like permutation. Remember when we did the letters yesterday? We did Winnipeg and we divided. I do the same thing. I can go 11 factorial over 8 factorial, 3 factorial. And then that gets me to the number of routes. So it'd be 165 routes for that. Okay? So this is another example of a like permutation. Now, I can set this up differently, which we will do eventually. So there's 3 of the north, right? Let's take a look at that. And then 8. 6. 7. Alright. Okay. So this is I'll quickly give you the lowdown on it, and then we'll actually look at a couple of examples from an old exam. How come I want to do it this way? So here's what happens. I'm going to go from A to B. So 8 blocks west, 3 blocks north. How many ways can I go from A to here or A to here? How many ways can I choose? How many decisions or how many choices do I have? 2. I have 2. I can either go north or west, right? But if I decide to go west, how many ways can I get there? If I decide to go from here to here, how many ways is there? There's only one way, right? Whereas if I go from here to here, how many ways is there to go?
2.
There's 2 ways, right? So here's what I do. I take a line and I draw it through the middle. I create a diagonal. Okay? And to go from here to here is 1. There's only one way in which I can do that. To go from here to here, there's only one way to do that. Now I create another diagonal right here. To get from A to here, still only 1. To get from A to here, also only 1, right? Is everybody following that so far? But what about from here to here? Well, I add 1 and 1 make 2. There's 2 ways to get there. Okay? How many ways are there to get to here? There are 1 and 2. 3 ways to get there. 1 here. How many ways to get to here? 4. And then I can keep going all the way across here. So this would be 3 here, right? This would be 4 again. 3 and 3 make 6 here. And then I just keep going. Okay, I'm going to go 1 again. Of course, my lines have to be terribly crooked, but don't really need these ones. I'm put them in. Oops, that's supposed to be right there. There's 1. Okay, and then so I keep going. 1 and 4 make 5 here. 6 and 4 make 10 here. 4 and 6 make, well, that's 1 there. There's that 4. 4 and 6 make 10 here. Okay, and then I keep going all the way across, and I'll get to there, and I'll eventually end up with 165. Okay, so there's a reason I do this, because if this is easy to do with a permutation when it's just there's no zigzagging. But what you'll get is you'll get this, and then you'll get another box down here. And then how do you get from here all the way over to there? And you can't do the permutations as easily. So you have to do this method, and then you'll find out. So you get 1, 1, 1 here, right? So this would be 2 here. You get to this point right here, and then you start this again. And then this would be 4, 4, 4, 4, 4, or whatever it is. So I will show you that method as we get into a more complicated question. For example, I think it's number 8 on page 1, 3. Oh no, sorry, it's number 5 already. Question 5, A and B. So on Monday we'll get at those, okay? So you can try them using this method and see if you can come up with the correct solution. All right, but we will look at that on Monday. So okay, so that's all I have. So you have 4.3 and 4.4 to look at today. Okay, quiet group for a Friday. Probably because the loud ones aren't here. Is that what is going on?
I'm a little sleepy.
You're a little sleepy. That makes 2 of us.
It makes all of us. Yeah. Let's be real.
This is chapter 4. Just counting principle.
Shit.
4.5. Okay. All right. You got the rest of the period today to work on 4.3 and 4.4. Okay. Read catching up.
You have